Today's daily LeetCode problem of the day is minimum number of pushes to type a word, part 2, number 3016. For this problem, we're given a string word containing lowercase English letters. The telephone keypads are mapped to a distinct collection of these lowercase English letters. So if we look for the example, the number 2 is mapped to A, B, and C. To get A, we type number 2 once. To get B, we type number 2 twice. To get C, we type it 3 times. We are able to remap all these keys from 2 to 9 to a distinct collection of letters. With this, we want to return the minimum number of key pushes it can take after remapping all the keys. So let's look at the example. For our input word, we have A, B, C, D, E. Typically, the number 2 would have A, B, C, number 3 would have D and E. However, because we are able to remap the keys, we want to put each of these letters on their own number so we don't have to push a number multiple times. So we could do 2 once, 3 once, 4 once, 5 once, 6 once, and then we get our output of 5. If we were to do that on a regular phone, we would have to push 2 once, and then press it twice, and then press it 3 times. So that would already be 6 pushes on the number 2 alone. But by remapping it, we're able to put each letter on its own individual key. We could continue with example 2. We have X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. To prevent having to push multiple times, we could put X, Y, and Z each on their own number, and that will lower the cost of total pushes we need to make in order to achieve our number. So, for this problem, we are going to keep track, like a frequency, of how many times each character appears. By keeping track of how many characters appear, we can decide which number we're going to put them on first, and then if we're going to have to push a button twice to reach them. We can calculate this because there are 1, 2, 3, 4, 5, 6, 7, 8 numbers in total that can store a number, or the characters. So once we reach our 8th character, it's going to reset, and then we can increase a multiplier to 2 because each time we want to find a character, it's going to require 2 presses instead of 1. So for this problem, we are going to create an array, and this array is going to be 26 spaces in length. That is because there are 26 characters in the alphabet. We are going to store the frequencies of each of those characters, and then we can do we're going to sort this array, and then we can do a simple calculation to determine how many presses are going to be needed by addressing the keys that need to be pressed the most first. So that way, if A needs to be pressed 10 times, it'll be on its own, or at the front. However, if F needs to be pressed only once, it can be a second letter if all these other spaces are taken. So we're going to initialize our integer array. We could call it ARR. It's a new integer array of 26 indices. We could then have an integer total, which is going to be the total number of presses that is going to be necessary to complete our string. We're then going to have a for loop for each character C in our word.toChar array. We are going to map the frequency of this character to our array. So, how do we do this? ARR of our character minus the character A because it's an integer, and we're just going to pre-increment this. So this will map the frequencies of each character. Then all we have to do is arrays.sort our array. So now all the high frequency letters are at the end of this array. So we're going to track those first. So we're going to put the most frequencies in the first spot, and then the less frequencies in the second spot. So what we are going to do is for int I is equal to 0, as long as I is less than, we have 26 spaces, I plus plus. So our total is going to plus equal our array of, and then we're going to look at the furthest most back first, because we want to put the most frequent letters first. So ARR of 26 minus I. So this is going to get our last most index and then work back to the first most index. But because it is 0 index, we're also going to have to subtract 1. And then we're going to multiply that by I divided by 8, because we have 8 letters, or 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. So I divided by 8 plus 1. So this is going to make sure that we only put, or that we can count how many presses it takes. So as long as I is less than 8, we are going to be able to put 1 character in each first spot. Then once it gets to 8, 1 divided by 8, or 8 divided by 8 is equal to 1, so 1 plus 1 is 2, so it's going to require 2 presses to reach that character. After that, we can simply return our total. And if we run this, passes our test cases. And if we submit it, passes all solutions. So let's do this in Python. So our solution for Python is pretty much the same. We're going to have a list array. It's going to be full of zeros. It's going to be of length 26. We're also going to have our total, which will be equal to 0. For each C in our word, we are going to add it to our array. So array of, and it's going to be the order of C minus the order of A. It's going to plus equal 1. Then we're going to do ARR.sort. Then we're going to loop back through. So for I in range 0 to 26. And then we're going to add it to our total. So total will plus equal ARR of 25 minus I. So we don't have to subtract the extra 1. So ARR of 25 minus I times I divided by 8 plus 1. Then we can return our total. So if we run this, pass our test cases, and if we submit it, passes all solutions. So thank you. Follow for more daily LeetCode solutions.